Hello, good morning, my dear students. So, today we are going to discuss the important topic, that is multiple alleles. So, multiple alleles. So, these multiple alleles, what are the multiple alleles? So, naturally, in any human beings, so, for each character is controlled by the pair of alleles in the locus of the chromosome. That means at the locus, the two alleles are present in all the characters, but here specifically in the some characters like blood groups, they are controlled by, regulated by more than three alleles, more than two alleles at the locus of the homologous chromosomes. So, if the alleles are more than two, they are called multiple alleles. More than two alleles are present on the locus of the homologous chromosomes. Such condition is called multiple alleles. The best example for the multiple alleles is blood groups in human beings. Blood groups in human beings. Blood groups in human beings. Blood groups. So, for the first time, the blood groups discovered by the scientist called Carl Landsteiner. Carl Landsteiner. Carl Landsteiner. Actually, in human beings, two types of blood grouping systems are present. So, one is called ABO blood groups. ABO blood groups. The second is called RH blood grouping. RH blood group. Okay. For the first time, the Carl Landsteiner discovered the ABO blood grouping in 1901. For that, he was awarded as the Nobel Prize in 1930. Okay, so the Carl Landsteiner classified the blood groups into four groups based on the antigens are present on the RBC. So based on the antigens. The antigens are present on the RBC, the human RBC. If the RBC antigens are A type antigens are present or B type antigens are present or no antigens based on the presence and absence of the antigens. These are four types. So they are okay. A blood group, B blood group, AB blood group and O blood group. Okay. In the A blood group, this is the RBC. This is the RBC. This is RBC. Okay. RBC. In the RBC, if the antigens are present, this is called A blood group. If the B antigens are present, B blood group. A and B antigens are present, this is AB blood group. No antigens here, this is O blood group. Okay, antigens are present on the RBC, but in their plasma, antibodies are present. These antibodies. These are antibodies. Antibodies. Okay. In the A blood group, the antibodies are anti-B antibodies. Anti-B antibodies. In the B blood group, the plasma is anti-A antibodies. In the AB blood group, AB blood group, antibodies are absent. In the A blood group, AB blood group, antibodies are no antibodies in their plasma. This we can say this. No antibodies. In the O blood group, in their plasma, anti A, anti B antibodies are present. Okay, so this is the antigen antibodies. So based on the antigen and antibodies, always there is a fight between antigen, antibody. This is antigen, this is a antibody. If the antigen enters the body, immediately the antibodies are released from the plasma. There is a clump is formed or agglutination is formed. So as a result of this, the recipient will die. So based on this, so the A blood group can donate to the A blood group can donate to A and AB persons. So B blood group can donate to B and AB persons. AB blood group can donate to only AB. So O blood group can donate to A, B, AB and O. So that the O blood group is known as universal donor, but AB blood group can receive from all these three, so that it is a universal recipient. Why it is a universal recipient? Because it is having antigens, but it is having A and B antigens. But if you take the no antibody, here it is having no antibodies. Always in the blood transfusion system, we have to consider the antigen of the donor antigen and recipient donor. As this AB blood group, no antibodies, it can receive any type of blood, so that it is a universal recipient, my dear students. Next, so this is the blood group, AB blood grouping. Next, if you take the antigen antibody fight, antigen can fight with anti A, but anti A is present in B blood group. B blood group. So the A type of blood cannot donate to the B blood group, because in the B blood group anti A antibodies are present. Anti A antibodies are present in the B blood group. So that this is the agglutination. What will happen here? If any antigen enters the body, immediately antibody reacts. This is, clump is formed. This is clump. So due to the clump, the recipient will die. So this is called agglutination. This is also called as agglutination. That is why during the blood transfusion, so these antigen and antibody reactions to be considered. Okay, so this is the types of blood groups. So one scientist Bernstein explained the inheritance of the blood groups. According to the scientist Bernstein, scientist Bernstein, the blood groups can be inherited by, transmitted by, so more than two alleles, that is three alleles, three alleles on ninth chromosome of human body, number 9. So according to the formula, if the alleles number is 3, the number of genotypes will be number of genotypes. How many genotypes we can expect? So that is a formula is there, n into n plus 1 by 2. If you take the 3 into 3 plus 1 by 2, that is 6 genotypes we can expect from the blood grouping system. 6 genotypes. What are the 6 genotypes? Okay, if you take the A blood group, there are two types of IA, IA, second is IA, IO. The B blood group, IB, IB, next IB, IO. In the AB blood group, IA, IB only. In the O blood group, IO, IO. Okay, so these are the genotypes. So if you take the A and B blood groups, if the father is A, mother is B, what type of genotypes in their offsprings? So we can see here, mother is, father is A, mother is B. Okay, A, always we have to take the heterozygous condition only. IA, IO, IB, IO. So if you take the gametes, because of the heterozygous condition, here we can take the two types of gametes. They should be encircled. Okay, IB, IO. If you take the cross, 1, 2, 1, 3, 2, 3, 2, 4. So this is called IA, IB, IA, IO, IO, IB, that is IB, IO, IO, IO. So these are the blood groups here, AB, A blood group, B blood group, O blood groups. If father is A blood group, father is having A blood group, mother having the B blood group, in their offspring, the possible blood groups are all 4 types, although in their parents O is absent. So this is the inheritance of the blood groups. So this is discovered by, this is explained by, so Bernstein, the scientist. So this is called as blood grouping inheritance or multiple alleles inheritance, my dear students. Thank you very much.